Okay, in the previous video, we have talked about what is correlation. Now let's take a look at an example of the correlation. So from the motivating example we have seen at the beginning of this handout, we are trying to find out the relationship between the pH of the water and the percent of arsenic that could be removed. So the first thing, as we have mentioned, we draw the scatter plot. The second thing, what if we try to calculate the correlation? So the formula to calculate the correlation of two quantitative variables is like this. You actually don't really need to remember this formula because we have the StatCrunch to help us to find it. I just want to show you, here is the formula, but it's not necessary for you guys to remember this formula. And besides, your final exam is open book or open note. So this is just here for your knowledge. Now let's see how we could use StatCrunch to draw the scatter plot and calculate the correlation. Let me switch to the sharing of this. Okay, so the data for the pH data values has been posted on Moodle here. And if you download it and open it, it's look like this. This Excel file, you just copy those and paste it to StatCrunch. So here is the data. And there are other ways to import the data in, from this data and so on. But let's just use the easiest way to copy and paste. So as I've mentioned, the first step is always to draw a scatter plot to take a look at what does the data look like. So you go to graph, go to scatter plot, and your x variable is your pH. That's your variable 2. The y variable is your removed arsenic. That's your variable 1. And you just leave all those as what they have been inputted here. You could adjust it if you want. Go compute. And this is the plot, scatter plot. And you can see it's pretty much it's actually the same as the plot you are seeing on the first page of your note, right? And this plot, we can see, remember there are 3 things that we want to say about a scatter plot. It's let's go back to the note. This we expect. So based on the plot, we would expect a strong and negative correlation, right? Now let's go back to StatCrunch and do our second thing to calculate the correlation. You go data, go stat. You try to calculate the summary statistic, and you are trying the correlation. So you try this variable 1 and variable 2. You click compute. So the correlation between variable 1 and variable 2 is negative 0.95. So if we go back The value here we calculated from StatCrunch is negative 0.95 here, which is what we expected, right? Based on the scatter plot, we did expect to see a strong and negative correlation, and the correlation we calculated matched our expectation. And if you guys still remember, when I try to, enter the data for variable 1, variable 2, when we try to calculate the correlation, it didn't ask me to specify which is x and which is y, because the correlation between x and y and the correlation between y and x are the same, right? They are talking about the linear association between x and y. And you can also see that easily from this formula. If you exchange the x and y, you switch all the x's to y and all the y's to x, you are having the same formula. So when you try to calculate a correlation, it doesn't matter which one is variable is x, which variable is y. So the correlation between x and y and the correlation between 1 and x are the same. So correlation of x and y is the same as correlation of y and x. There is a second thing that I want to talk about is correlation does not equal to causality. So a very typical example is, say, now is we are coming to summer now, and people are enjoying some water time. They go to swim. And also, we could see the increase in the consumption of ice cream. So we could see a positive relationship between the consumption of the ice cream and the number of drowning. I mean, by drowning, I mean, you go to the swimming pool and you couldn't get up. You got a lot of water in your lung and you got suffocated. So you can see there is a positive relationship between the consumption of the ice cream and the number of drowning. And that doesn't mean that eating ice cream causes you to drown. So correlation does not equal to causality. Another example, when there is a big fire, there will be more firefighters on the site, and there will be a lot of damage done by the fire. So they collect data, right? They collect X and they collect the Y, and they find there is a positive correlation between the number of firefighters at the fire site and the damage a fire does. So they said, okay, it was the firefighter who caused the damage of the fire. That's absolutely not right, as you can see. So the correlation only talks about the linear relationship between the two variables, x and y. There may be a positive correlation there, there may be a negative correlation there, but that doesn't mean anything, especially this is not a cause and effect relationship between x and y. So this is the end for this video.